Hello, my name is Alicia Lungo, and I am here with Abigail Goslin and Elias Bitzarakis. We make up the Management and Engineering for Manufacturing Senior Design Team 6. Our project was joint with Ryan Hunter and Alex Roston, two mechanical engineering students. We worked with Holochrome and our sponsor Andrew to create manufacturing agility for their production floor. When given our project, there were many areas of improvement that we had the opportunity to focus on. After analysis, we determined that creating an agile manufacturing cell for the new Nedmax machine would be a great way to use our business and engineering knowledge to make an impact on the facility. The criteria we created for our solution was that the design must be feasible in the space allocated, must be structurally obtainable with respect to vibration, must allocate the necessary space for the new accurate and efficient machine, must meet fluctuations in demand and contain the appropriate machines, and finally, it must keep moving costs to a minimum.
We took a four-phase approach to this project. During the fall semester, we started with a thorough initial state analysis by creating an initial state CAD model and benchmarking the initial state profit to square footage ratios. We also visited the facility to talk with employees and gain a better understanding of the processes. After this, the second phase was to identify areas of improvement. We considered whether one or multiple cells should be redesigned while looking for opportunities for cost or energy savings. We also considered overall flow and whether that could be improved in certain areas. For the third phase of brainstorming and testing, we researched agile manufacturing as this was our most promising improvement initiative. We collaborated with industry experts in order to develop 3 future state plan options. This led us to the final stage of implementation and recommendations. We researched and developed employee adoption and training plans to ease change management. We also looked into costs of moving machines. And lastly, we analyzed our results and made recommendations for the company to continuously improve using our approach.
Our solution began in the black team after benchmarking when we found the majority of the trimmers in this cell are underutilized. With the possibility of moving some of these machines into the adjacent wire store, our team was able to devise the following plan. Please note the CAD layout depicted is formatted to show all relevant cells, and not in the actual layout of the facility. Once the underutilized black team trimmers are moved out of the way, shown in that green circle, this then gives room to move 89 National number 15 and 16 into the freed up space, which is shown from the orange arrow. Above the maroon team is the orange team, which is depicted on the left of the CAD file. By moving 89 National number 12 out of the way, which was depicted in that top red circle, it becomes possible to shift the entirety of maroon team up into that space. This then allows for a human cell to be placed in the bottom of maroon cell, and that original 89 National number 12 to be placed in human cell. With this complete, we then have adequate space enough for 3 new machines.
We benchmarked the initial layout by calculating the profit to square footage ratio for each team. We used 2018 annual profits and divided by the square footage of each team. This calculation was then repeated for our potential redesigns using projected profits and the updated square footage so that the benefits could be quantified. This redesign allowed for a more even distribution of profits. In addition, enough space was created to accommodate 2 new machines in the orange team, which will recoup any profit losses from the redesign. With the addition of the new machines, total profits will increase for Holochrome without expanding, all because the floor space was used more effectively. Efficient use of space benefits the company.
Depicted here is an Ishikawa diagram, which is traditionally used to highlight the key sources of failure for new projects. The goal was to create an agile system for the black team trimmers in order to allow their process to be completed as they were before, but now with less machines. If you look under the materials section, a key point to highlight is allocating space for raw materials, since space usage in the facility is already an issue. Along with this, underneath the personnel section, lack of knowledge of the machines in the cell may be a hurdle which can hinder production levels during the beginning phases of implementation. Finally, resistance to change under the personnel section as well may be the largest challenge to overcome, which will be discussed in the next slide. However, due to the modular design of Holochrome's products, along with already being able to forecast demand accurately, the company is in a great position to begin their agile transition.
When implementing an agile cell, change management plays a major role in its short-term and continued success. Before making this change, it is important for the employees to understand the need for the agile cell and how they will be impacted by this change. Management will be in charge of easing this transition, but should also be open to communication and collaboration from the employees. Our recommendation is to find staff that are more adapting to change and allow them to work in this cell. With a team that is ready to learn and participate, the success of the Agile Cell will only be better.
Finally, we just want to thank our sponsor, Andrew Ehler, as well as our professors, Dr. Craig Calvert, Dr. Jason Lee, Dr. Frank Cunha, and Dr. Diane Van Scoter. Thanks for all your advice and guidance throughout this project. You were truly instrumental in its successful completion.